Just for the video wise, I'm starting it here so that if you need to go back and look at the wording for anything. So I'm starting the video here. So if you want to redo it, like pause it here and then keep on whatever. But then there's the chart instead of the words. And if you're still working on the stuff at the bottom, that's fine. It's the stuff that the first couple should be pretty easy to go through. For probability of boy, what do you have? That is a marginal probability. That one should be just looking at the chart and reading correctly. What is probability of hoodie? And I don't need to show any work for that because all I'm doing is reading the two-way table. If this were a tree diagram, in order to find probability of boy, then I would possibly have to take different paths and do what with them? Add them up to get the total of them that were boy. What does this symbol mean? Well, that makes it super easy in a tree diagram or in a two-way table because it's just where they what? So they overlap at 5. The place where some people get mixed up, what number goes on the bottom? The overall total, the 15.
I get confused because I thought that was like the given thing when you get where there. When you go over 1 and 1. I thought that was when you do given.
Given means I'm only looking out of something. I'm given that I'm not dealing with the total.
Okay, so both of them, like both, is that
the
what's
numerator
given and is that what's in the numerator and
right.
the denominator? Okay. Given would be out of the total.
Mm-hmm. So then, what does E say in words?
Probability of boy or
I'm doing this to have a little bit more room. Probability of boy or hoodie. So how would I rewrite that?
probability of boy plus minus probability of boy and
You know what? The question you just asked, I want to make sure. So the question that she asked, because I was told that sometimes they can't hear what y'all say, that was a good question. With this being 5, they're confused about that versus a conditional. In a conditional, the top is still 5. Here is out of the overall total when it's and, but in a conditional, that's out of a specific total, not the overall total. All right, and then, so we already have all of these now. So what is, with the not reduced version, what was probability of boy? 8 out of 15 plus minus, which gives us and has nothing to do with the context that we're dealing with right now, but I heard people asking, having conversations, and this got brought up yesterday. Or means it can be one, or it can be the other, or it can be both. And I think some people were fighting themselves on that idea, but yeah, or means it can be this, or both. Where do you find this in a tree diagram? So if I had 2 levels, how would I figure out what the and is?
Probability of each level.
Multiply each level, so it'd be like the multiplying of half. So it'd end up being like.
so for that one, would we do 8 over 15 and 6 over 15?
It'd be different. Like you'd look at it differently. So it'd actually be, if this were boy, what's probability of boy? Now, if I were drawing it as a tree diagram, that means of my boys. So how many boys were there? How many boys were there? How many of them had on a hoodie? So it'd be multiplying that times that, which still gives you the same answer.
Because I was trying to do probability of A and probability of B, like, because that's the and thing.
But they're not independent.
Oh, you can only do that. Okay.
And then this last one is a what kind of problem? A given, or what's the other thing we call it? Conditional and given are the same thing. That's another conversation I heard yesterday. So most of you can easily explain to me what conditional is, and then you try to think about what goes where and you confuse yourself. It is under the condition that we are dealing with what? With this one. What's my condition? So I'm only dealing with this, right? So it's only out of the hoodies. So if I wrote this as an equation, which you don't need to here because it's a two-way table, but you would have the and on top, and people always confuse themselves, well, I don't know which one to put on bottom. Well, you just explained to me what goes on bottom. We're only dealing with what? So that's what goes on bottom. The condition is what goes on bottom, so we're only dealing with those. But when I'm looking at a tree diagram or a two-way table, it gets super easy. I circle this like mentally circling this like I'm only dealing with these. How many of those are a boy out of the total? So in a two-way table, you can look at it and go straight to the answer as opposed to a problem where you would have to go through that equation. Are boy and hoodie mutually exclusive?
No.
Why?
Probability of boy and hoodie is not equal to 0.
And most of you are gonna, if I asked you to say why, about 25% of you would have written this. But everybody else would have gotten it right. Everybody else would have gotten it right, would have written something else, but they're actually saying the same thing. What would you tell me? They overlap. What does this mean? They don't overlap. So this is saying they don't. The overlap is not 0, which is saying in words they do overlap. Are boy and hoodie independent? What do I check? And so why did I choose to go with boy given hoodie and not hoodie given boy? Does it matter which one I use?
No.
So if I already found one, should I use it? Yes. If I instead used this one, probability of hoodie given boy, that one I would now need to compare to what? Because whatever goes here has to be the same. But, so what was our probability of boy? What was our probability of boy given hoodie? So these are not equal, which means it is, which is part of the reason why when you guys are like, well, can't I just say dependent? Yes, but if they're not equal, they're not independent. Is an easy way to help remember that. Is part of why I choose to do it that way. Any questions with this problem? It just kind of goes through a little bit of each. Equations. What's my equation for probability of A or B?
Probability of A plus probability of B minus probability of A and B.
This is technically the equation for every single possible option, but sometimes we write it different. How do we write it different sometimes? Sometimes we do what is not there. Sometimes this part is not there because if it's what, this is 0. Which means do I need to write it? No, if it's mutually exclusive. So this is technically always your equation. It just so happens that if they're mutually exclusive, that's 0, so I don't need to include it. We just talked about this one. What is probability of A given B?
Probability of A and B over probability.
So it's out of the condition and divided by the total of the condition. What's our equation for A and B?
Probability of A times probability. No.
Probability of A times probability of B given and.
This one is just saying A given B, and this one is saying B given A. But if I redo this math, that's the same equation here, except I'm just saying which one came first. So this equation gives you both of these.
I'm confused what you just did.
Here, multiply probability B to both sides, instead of just rearrange the equation. Binomial, what's my equation for probability? If I had to write it out in an answer,
Okay. Probability
letter,
of P,
To the end.
what's it take?
successes,
B
so this
minus
is,
1.
1 minus
Okay, one minus one.
what's my equation for binomial mean?
NP.
What's my equation for binomial standard deviation?
Square root.
Probability equation for geometric. Okay, let's look at this one. What's going on here? This is probability of success, number of successes, right? Probability of failure, number of failures. So I am doing geometric until I get a what? Until I get one success. So I'm essentially starting with that part. The fact that we write it on the end doesn't really matter. So how many of these do I want? How many failures do I want?
1 less than
One less than the amount of trials. What's my equation for geometric mean? What's my equation for geometric standard deviation? How do I check to see if two events are independent? I'll go back to it in a second. Hang on. There's a reason why I'm gonna wait to get back to it, but yes. Independent if what? We just did this one.
Probability of, I guess,
Just pick a letter.
A. They would have to be equal to probability of A given B.
Which means if they're not, then it's not. Based off of what we were just writing, what's the easy way to tell if events are mutually exclusive?
Probability of A and B equals 0. Equals 0. Oh.
Wait.
So,
Yes, it is equal to 0. Because the one we did was not, right? Yeah.
and you find Android and probability of A times probability of B.
Conditional. Like probability A times probability B given A. This is something that you are given on the AP exam. We're gonna go through these one at a time. What is this? Mean equation. What is this? Standard deviation equation. It's just we usually write it with n-1 below that right here as opposed to over here, but same thing. Never heard of it, never heard of it, never heard of it. Nothing over there we have covered yet. So start back over here. Or given. Well, what else? Other equation do I get out of that? And so just rearrange it. What's this equation? Mean when I'm given it as a what? Like what does it visually look like? I have a what in front of me if I want to use that equation. Probability table. So like if it's one of those. I don't know where I was. I'm on a different one, but it's still the same thing. So that gives me, I'm adding up my x's times my p of x. This is the variance of that same thing, which means to get standard deviation, I just do what with that? Square root. This is the only words it gives you on, or only helpful words it gives you on this whole page. This is telling you that it's a binomial. So this is your equation for what? Binomial probability. So this is binomial. So what is this the mean to? Binomial. What is this standard deviation to? Binomial. We don't know anything else on that page. We don't know anything else on this page. So if I give you this and you don't know what they are or when to use them, this isn't helpful at all. If you know which ones are ones to use and when to use them, this becomes very helpful. I give you this. I'm giving you the same thing you get on the AP exam. So, looking at the ones we just wrote, do you get this one on the equation sheet?
Yes.
Yes, you just have to know that this is 0 if it's mutually exclusive. You get this one on the equation sheet.
Yes.
Do you get this one?
No.
But,
We get this for our test?
yeah, but it's that one.
Yeah.
Does it give you this one?
Yes.
Does it give you this one?
Yes. Yes.
It does not give you anything with geometric. So that you have to know. And I don't know why. I hate that it doesn't. It's the one that's used the least, so I think it should be the one that's on there, but whatever. And it's not going to give you either one of these, obviously. So it's going to give you some tools if you know when and how to use them.